Before we begin, please remember that I am not a financial advisor, and this presentation is for educational and informational purposes only. The career path and salary figures discussed represent potential outcomes based on market data and personal experience, but your individual results are not guaranteed and will depend on your effort, location, the job market, and a variety of other factors. This video outlines a roadmap, not a promise of employment or a specific income. What if I told you that the most valuable piece of real estate in the 21st century isn't on a beach in California or in a high-rise in New York City? It's invisible. It's a collection of servers humming away in a data center in Virginia or Oregon. And the people who know how to manage that invisible real estate are quietly becoming some of the highest-paid professionals in America. I'm talking about cloud computing, and I'm talking about a career that can realistically take you from where you are right now to $150,000 a year, without a 4-year computer science degree and without going 100 grand into debt. Look, maybe you're like I was. Maybe you're working a job that pays the bills, but just barely. You feel stuck. You see headlines about layoffs, about AI taking jobs, and you feel a knot in your stomach because you know your career isn't future-proof. You drive to work, sit in a cubicle or stand on your feet all day and you think, is this it? Is this all there is for the next 30 years? You're smart, you're a hard worker, but you feel like you missed the boat on the whole tech thing. You think it's too late, that you're not a coder, that you're not a math genius. I am here to tell you that is a lie. The boat hasn't sailed. In fact, the biggest ship is just now leaving the harbor, and it has a giant sign on it that says Cloud Engineers Wanted. No experience necessary to apply. Corporate America has a massive multi-billion-dollar problem right now. They are moving everything, their websites, their data, their applications, their entire digital operations into the cloud. Think about it. Every time you stream a movie on Netflix, order something from Amazon, or post a photo on Instagram, you are using the cloud. The biggest companies in the world, from Ford to Coca-Cola to the US government, are built on this invisible infrastructure. And they are desperately, frantically looking for people who know how to build, secure, and manage it. There are hundreds of thousands of open cloud computing jobs in the United States right now. Not in 5 years. Now. And they're not being filled fast enough. Why? Because most people don't even know these jobs exist. They don't know there's a direct path to get them. That's what this is. This is the path. This is the roadmap I wish someone had given me. No fluff. No gatekeeping. No selling you $1,000 boot camp. This is the step-by-step blueprint to take you from zero to a high-paying cloud professional. Over the next several parts of this series, we are going to break it all down. We're going to start from the absolute beginning, assuming you know nothing. What even is the cloud? We're going to cover the fundamental skills you need, the holy trinity of networking, operating systems, and security that form the bedrock of everything else. Then we're going to pick a lane. Are you going to be an Amazon Web Services expert? A Microsoft Azure specialist? Or a Google Cloud guru? I'll break down the pros and cons of each and help you decide which platform is the best fit for your career goals right here in the American job market. From there, we get to the fun part, certifications. These are the golden tickets. I'm going to show you which specific entry-level certifications are the most respected by hiring managers. These are the pieces of paper that get your resume past the bots and into the hands of a real person. I'll lay out exactly what you need to study, how to study it, and how to pass these exams on your first try. But we're not just going to be paper certified. We're going to build things. I will walk you through creating a portfolio of real-world projects that you can show to employers. You'll learn how to launch a web server, build a database, and automate tasks, skills that will make you look like a seasoned pro, even if you just started a few months ago. And finally, we're going to master the job hunt. How to build a killer resume that highlights your new skills. How to optimize your LinkedIn profile so recruiters come to you. And most importantly, how to walk into an interview and crush the technical and behavioral questions so you can walk out with a job offer that will change your life. This isn't a get-rich-quick scheme. It's going to take work. It's going to take focus and dedication. You might have to spend your weeknights studying instead of watching TV. You might have to invest a few $100s in exam fees instead of going out. But compare that to the alternative. 4 years and a mountain of debt for a traditional degree? Or spending the rest of your life in a job you don't love, for a paycheck that doesn't reflect your true worth? The opportunity in front of you is immense. This isn't just about getting a bigger paycheck. It's about getting your time back. It's about having the freedom to work remotely. It's about having skills that are in such high demand that you are no longer at the mercy of one company. It's about building a stable, future-proof career for yourself, and your family in a world that feels anything but stable. So let's get one thing straight before we go any further. You can do this. I don't care if you're a truck driver, a barista, a teacher, or a stay-at-home parent right now. Your past does not define your future in this industry. Your ability to learn and your drive to succeed are the only things that matter. The tech industry, especially cloud, is one of the last true meritocracies in America. If you can do the job, you get the job. Period. So if you're ready to stop feeling stuck and start building a career that truly excites you, you're in the right place. We're about to lay the first, most critical brick in your new foundation. This is where we separate the dreamers from the doers. Because the first step on this $150,000 roadmap isn't learning to code, and it isn't buying a textbook. It's making a fundamental mindset shift that will set the stage for everything that follows. This shift is the difference between being a passive consumer and an active builder. It's moving from what I call the student mindset to the engineer mindset. And trust me, this isn't some feel-good motivational fluff. This is the tactical operating system that will run in the background of your brain and determine whether you succeed or fail. Let's break it down. The student mindset is what we've all been trained for since we were 5 years old. Sit down, be quiet, listen to the lesson, memorize the facts, and pass the test. The goal is to accumulate knowledge. You buy the online course, you watch the videos, you read the textbook, you get the certificate. Feels productive, right? You're checking boxes. You're learning. But in the world of tech, and especially in cloud computing, this is a trap. It's the fast lane to what we call tutorial hell. You know what I'm talking about. You've spent weeks, maybe months, watching video after video. You can explain the difference between an EC2 instance and a Lambda function in theory. You've got a folder on your desktop overflowing with bookmarks and PDF guides. But when a blank command line screen is staring back at you, you freeze. You're asked to actually build something, to solve a problem you haven't seen in a tutorial, and suddenly all that knowledge feels like a pile of useless trivia. The student mindset makes you a collector of information. The engineer mindset turns you into a solver of problems. The engineer doesn't ask, "What topic should I learn next?" The engineer asks, "What problem do I want to solve?" This is the most important reframing you will ever do in your career. Changes everything. Let me give you a real-world example. Someone with the student mindset says, "My goal is to learn AWS. I'll start with the AWS Certified Cloud Practitioner certification." So they buy a course, they memorize the names of dozens of services, S3 for storage, EC2 for compute, RDS for databases, and they pass a multiple choice test. They get a shiny badge for their LinkedIn profile. And then, nothing. They can't build anything. They can't solve a business problem. They're a walking, talking AWS service catalog, and nobody pays $150,000 for that. Now, let's look at the person with the engineer mindset. They don't start with the certification. They start with a problem, a simple, tangible problem. They say, "You know what? I'm tired of my personal website going down all the time on my crappy $10 a month web host. I want to build a website that is highly available, that can survive a server crash, and can handle a sudden spike in traffic if one of my blog posts goes viral. How can I do that?" See the difference? The goal isn't learn AWS. The goal is build a resilient website. AWS just becomes the box of tools you use to achieve that goal. Suddenly, your learning has purpose. You're not just memorizing what S3 is. You're diving into S3 because you need a place to host your website's images and files that's durable and scalable. You're not just learning about EC2 because it's on a test. You're learning how to launch 2 smaller EC2 instances instead of one big one, and how to put a load balancer in front of them so if one fails, your site stays online. You're learning about Route 53, not as a vocabulary word, but as the tool you need to direct traffic to your load balancer. You are not learning topics. You are solving problems. Every service you learn, every command you type, is a weapon you're adding to your arsenal to solve a real-world challenge. This is how real engineers think. It's how they work. And it's the only way to truly learn this stuff so that it sticks. Because here's the brutal truth about cloud computing. It is impossibly vast. Amazon Web Services alone has over 200 distinct services. 200. And they launch new ones all the time. If your goal is to learn AWS, you will fail. You will be forever chasing a moving target, constantly feeling overwhelmed and behind. It's a recipe for burnout. But if your goal is to solve problems using AWS, you only need to learn the handful of services relevant to your specific problem. You learn them deeply. You use them. You break them. You fix them. That knowledge becomes real. It becomes a part of you. Then, you move on to the next problem and you learn the next set of tools. This is how you build a skyscraper. You don't try to memorize the Home Depot catalog first. You focus on laying the foundation. Then you focus on framing the first floor. You learn about concrete, then rebar, then lumber, then drywall as you need them in the context of the project. Companies don't hire you for the certificates you have. They hire you for the problems you can solve. Your resume, your interview, your entire career trajectory will be defined by the things you have built, not the courses you have completed. A hiring manager in San Francisco or Austin or New York doesn't care if you passed a test. They care if you can look at their broken, inefficient, expensive system and say, I can make this better. I can make it faster. I can make it cheaper. I can make it more reliable. Here's how. That ability, that confidence, that mindset is what commands a $150,000 salary. So your first step on this roadmap isn't to sign up for an AWS account or buy a book. It's to make a conscious, deliberate decision right now to abandon the student mindset that has been ingrained in you your entire life. You are no longer a student. You are an engineer in training. You are a builder, a problem solver. And your first mission is simple. I don't want you to watch another technical video for the next 48 hours. Instead, I want you to find a problem, a small one, something that affects you, your family, or your community. Write it down on a piece of paper. Not the solution, just the problem. Maybe it's, my friends and I can never agree on a place to eat. I want a simple app that lets everyone vote. Or, my mom's small business has a terrible, outdated website that I want to rebuild for her. Or even simpler, my personal files are a mess, spread across 3 different hard drives. I need a single secure backed up location for everything. Define a problem, a mission, because that mission is going to be your North Star. It will guide your learning and keep you from getting lost in the overwhelming sea of information. It transforms learning from a chore into a quest. Once you have that builder's mindset locked in and you have your first mission defined, you're ready to lay the first block of your technical foundation. We're not jumping into the complex world of AWS or Azure just yet. That would be like trying to build the roof before you've even poured the concrete. No, we have to start at the absolute bedrock. The universal language of the entire cloud. The operating system that powers nearly every server you will ever touch. And mastering its fundamentals is the first non-negotiable step to becoming a true cloud engineer. I'm talking about Linux. And before you click away, thinking this is some boring old-school technical deep dive, let me be crystal clear. If you skip this step, you will fail. It's that simple. Trying to become a cloud engineer without knowing Linux is like trying to become a novelist without knowing the alphabet. It's the foundational layer upon which everything else, and I mean everything else in the cloud, is built. Think about it. That massive global infrastructure of Amazon Web Services? The servers are running Linux. Microsoft Azure, even with its Windows roots? Over 60% of their workloads run on Linux. Google Cloud? Linux. The containers that power modern applications with Docker and Kubernetes? They are fundamentally Linux processes. The serverless functions, the databases, the web servers, it's all Linux all the way down. Ignoring Linux is choosing to be a mechanic who refuses to learn how an engine works. You might be able to change the oil or replace a tire, but you'll never be able to diagnose a real problem. You'll never be the person they call when things get tough. And you'll never command that $150,000 salary, because you'll be fundamentally limited. The person who understands the command line is the one with the keys to the kingdom. So how do we conquer this beast? We don't try to memorize a 1,000-page manual. That's a fool's errand. Instead, we focus on a core set of skills, a mental model that will allow you to solve any problem you encounter. We're going to build your Linux toolkit piece by piece. First, you need a place to practice. The biggest mistake people make is getting stuck on the setup. Forget dual booting your machine or buying a new computer. If you're on a modern Windows computer, your golden ticket is already built in. It's called WSL, the Windows subsystem for Linux. In about 10 minutes, you can have a fully functional Linux terminal running directly on your Windows machine. It's the lowest friction, fastest way to get your hands dirty. If you're on a Mac, you're in even better shape. macOS is built on a Unix-like core, so its terminal is nearly identical for all the basics we're about to cover. Once you have that black box with a blinking cursor open, your journey begins. Don't be intimidated. That cursor is waiting for your command. It's your entry point to controlling the digital world. We start with the 3 most fundamental commands for navigation. Imagine you've been dropped into a massive dark warehouse with millions of filing cabinets. The first thing you need to know is, where am I? That command is pwd print working directory. It tells you your exact location in the file system. Next, you need to see what's around you. You need to turn on the lights in the current room. That command is ls for list. It shows you all the files and folders in your current directory. You'll use this command more than almost any other. It's your eyes. Finally, you need to move. You see a filing cabinet labeled projects, and you want to go inside. The command is cd for change directory. So you type cd projects. Now you're in a new location. How do you confirm? You use pwd again. What's in here? You use ls. See the pattern? pwd ls cd. Where am I? What's around me? Let's go somewhere else. With these 3 commands, you can navigate any Linux system in the world. Now that you can move around, it's time to interact with the environment. Let's create things. Want to create an empty file like a blank sheet of paper? The command is touch. So touch my new file.txt. Boom, it exists. Want to create a new folder, a new filing cabinet? That's dir for make directory. Dir my new folder. Okay, so we can create things. How about managing them? You need to copy that file. The command is cp for copy. You type cp my new file.txt my new folder /. You just copied the file into your new folder. What if you want to move it instead? The command is mv for move. It's the same logic. mv my other file.txt my new folder /. mv is also used to rename files. To rename my new file.txt to importantnotes.txt, you just type mv my new file.txt importantnotes.txt. And finally, the most powerful and dangerous command in your basic toolkit, removing things. The command is rm for remove. rm importantnotes.txt. And it's gone. Forever. There is no recycle bin. This is a critical lesson. The command line does exactly what you tell it to do instantly. This is why it's so powerful and so dangerous. You will inevitably hear horror stories about the command rf/. That command tells the system to recursively and forcefully delete everything starting from the root directory. It's the digital equivalent of detonating a nuclear bomb in your data center. Don't ever run it, but understand the power you're wielding. So now you can navigate, create, and manage files. But what about looking inside them? To quickly dump the entire contents of a file to the screen, you use cat, short for concatenate. It's like ripping the pages out of a book and throwing them all on the floor. For longer files, this is a mess. A much better command is less. It lets you view a file page by page, scrolling up and down. It's a simple read-only view. But what if you need to edit the file? Change the text inside? For beginners, the friendliest tool is Nano. It's a simple, no-frills text editor that runs right in your terminal. You type nano myfile.txt, make your changes, and follow the on-screen commands to save and exit. As you get more advanced, you will encounter the legendary editor known as Vim. It's incredibly powerful but has a steep learning curve. Don't worry about that now. Master Nano first. Learn to edit configuration files without ever leaving your terminal. This skill alone will put you ahead of so many people. The last piece of this foundational puzzle is permissions. This is the security guard of the Linux world. Every file and folder has rules about who can read it, who can write to it, and who can execute it. The command to change these rules is chmod, for change mode. You'll see files with permissions that look like RWX. That's read, write, execute. You'll learn how to assign these permissions to the file's owner, to a group, and to everyone else. This is the bedrock of security in the cloud. Understanding chmod isn't just about commands. It's about understanding how to protect your systems. pwd ls cd. Touch dir cpmvrm. Cat less nano. And chmod. These 10 commands are your starting block. They are your alphabet. For the next 2 weeks, your only job is to live in the terminal. Don't use your mouse to create a folder. Use dir. Don't download a fancy text editor. Use Nano. Force yourself to use the command line for everything. It will be slow at first. It will be frustrating. But then something will click. You'll start to feel the speed, the power. You'll feel yourself thinking in commands. This isn't about memorization. It's about building muscle memory. It's about transforming that intimidating black box into your single most powerful tool. Because once you are comfortable here, once the command line feels like home, you are ready to build. You've mastered the language of the servers. You've laid the foundation, poured the concrete. But a foundation is useless on its own. It needs a structure. It needs to connect to the outside world. Now it's time to learn how these machines talk to each other. It's time to understand the invisible web of connections that makes up the entire internet and every single cloud network on Earth. It's time to talk about networking. Think of networking as the circulatory system of the digital world. It's the invisible high-speed network of arteries and veins that carries the lifeblood data. From a server in a Virginia data center to a smartphone in your hand in California, in less than a blink of an eye. Without networking, the cloud is just a bunch of very expensive, very lonely computers sitting in a warehouse. They can't do anything. They can't serve a single web page, process a single credit card transaction, or stream a single second of video. And here's the $1 million secret, or in our case, the $150,000 secret. Many people trying to break into cloud computing skip this step. They jump straight to learning AWS or Azure services, but they don't understand the fundamental rules of the road for how data moves. This is a catastrophic mistake. It's like trying to become a Formula One driver without knowing what a traffic light means. When an application goes down, and the company is losing thousands of dollars every minute, the person who understands networking is the one who can diagnose the problem. Is it a DNS issue? A misconfigured firewall rule? A routing problem? The person who can answer those questions is the one who becomes indispensable. They're the ones who get the promotions and the massive paychecks. This knowledge is your superpower. So let's build that superpower. We're going to use a simple analogy. A massive global postal service. First, every device connected to a network needs an address. Just like your house has a street address so the mailman can find you, every computer, server, and smartphone has an IP address. It looks something like 172.217.14.228. It's a unique identifier. Now, you don't type that series of numbers into your browser to get to Google, do you? No, you type google.com. This is where the DNS or domain name system comes in. Think of DNS as the planet's biggest, most efficient address book. When you type google.com, your computer sends a quick message to a DNS server saying, "Hey, I need the real street address for google.com. The DNS server looks it up in its massive directory and replies, "Sure, that's 172.217.14.228. Now your computer knows exactly where to send the mail. Okay, so we have the address. Now what about the mail itself? When you send a large file or even just request a web page, you don't send it as one giant single package. That would be incredibly inefficient. If that one giant package got lost or corrupted, you'd have to start all over again. Instead, the internet breaks your data down into tiny pieces called packets. Imagine you want to mail a 1,000-page book. Instead of putting it in one giant, heavy box, our digital postal service puts each page into a separate, small envelope. Each envelope is labeled with the destination IP address, the sender's IP address, and a number like page 1 of 1,000, page 2 of 1,000, and so on. These little packets are then sent out onto the network. This is where routers and switches come into play. A switch is like the mail sorting room inside your office building. It knows which cubicle belongs to which person, so it directs internal mail, data going between computers on your local home or office network, very quickly. A router is the long-haul mail truck driver, and the traffic controller combined. It connects different networks together. When your packets leave your home network and head out to the internet, the router looks at the destination address on each packet and makes a split-second decision on the most efficient path to send it on its journey across the globe. Some packets might go through Dallas, others through Chicago, it doesn't matter. They all know their final destination. When all these thousands of little envelopes arrive at the destination server, another system puts them back in the correct order 1, 2, 3, 4 and reassembles the book. This whole process, the rules for addressing, breaking down data into packets, and ensuring it all gets there reliably, is governed by a set of rules called TCP/IP. It's the universal language of the internet. It's the agreed-upon set of procedures that makes this entire global postal service work. Finally, we need security. You wouldn't want just anyone to be able to walk into your company's mailroom and read sensitive documents. In networking, this security guard is the firewall. A firewall is a device or software that sits between your private network and the public internet. It inspects every single packet trying to come in or go out. It has a strict set of rules. For example, a rule might say, only allow packets that are requests for our public website. Block everything else. Or do not allow any packets from this known malicious address. A firewall is your first and most critical line of defense in the digital world. Now let's tie this all back to the cloud and your future $150,000 job. When you use a cloud provider like AWS, you're not just renting servers. You are renting your own private, customizable section of this digital postal service. This is called a VPC, or Virtual Private Cloud. Think of it as AWS giving you your own private secure postal district. Inside your VPC, you are the Postmaster General. You decide the address ranges. You create different neighborhoods called subnets. You might create a public subnet, which is like a neighborhood with PO boxes accessible to the public internet. This is where you'd put your web servers, the ones that need to talk to your customers. Then you'd create a private subnet, which is like a gated community with no public mail access. This is where you put your databases full of sensitive customer information. They can talk to the web servers in the public subnet, but the outside world can't get to them directly. You, the cloud engineer, design this entire system. You set up the routes, you configure the firewalls called security groups and network access control lists in AWS to control exactly which packets are allowed to go where. And what happens when your website becomes massively popular and millions of requests, millions of letters are flooding in every minute? You use a service called a load balancer. A load balancer is like a genius mailroom supervisor. Instead of sending all million letters to a single overwhelmed server who will quickly collapse under the pressure, the load balancer intelligently distributes the incoming traffic across a whole fleet of identical servers. It ensures the workload is balanced, no single server gets overloaded, and the website stays fast and responsive for every user. Understanding how to configure a VPC, subnets, and a load balancer is not an optional skill. It is a daily requirement for most cloud jobs. So what is your mission now? Your goal is to master these fundamentals. The industry standard certification that proves you have this knowledge is the CompTIA Network Plus. This is your driver's license for the internet. Even for a cloud-focused role, having this on your resume tells a hiring manager in the US that you are not a rookie. It says you've done the hard work of understanding the foundation upon which everything else is built. To get there, you don't need a 4-year degree. The best resource on the planet is Professor Messer's free Network Plus training course on YouTube. It's comprehensive, it's clear, and it's free. Watch every single video. For practice exams which are critical, look at Jason Dion's courses on Udemy. Wait for a sale which happens constantly, and you can get his entire package of study guides and realistic practice tests for about $15. This combination is the gold standard. But don't just watch videos. You have to get your hands dirty. Open the command prompt on your Windows PC or the terminal on your Mac. Learn to use basic commands like ping to see if you can reach a server, traceroute to see the exact path your packets are taking across the internet to reach a destination, and IP protocol configuration or ifconfig to see your own computer's network address. This makes it real. You're no longer just learning theory. You're actively participating in the global network. Mastering networking transforms you from someone who just uses technology into someone who understands it. And that understanding is what companies are willing to pay top dollar for. You'll be the one in the room who can solve the tough problems because you see the entire system, from the physical server to the invisible data packets flying through the air. You've now learned about the machines themselves with Linux, and you've learned the language they use to speak to each other with networking. You have the 2 foundational pillars of the entire cloud. But how do you take 1,000 servers, 100 firewalls, and a dozen load balancers and build them all, configure them, and connect them together in a matter of minutes, not months? You can't do it by hand. You need to learn how to write the blueprints for the cloud itself. You need to learn how to command an army of computers with code. It's time to learn the most powerful and highest paid skill in the modern cloud landscape. It's time to talk about automation and infrastructure as code. It's time to talk about automation and infrastructure as code. Let's imagine 2 home builders. The first builder, let's call him Chris, is a master craftsman. He shows up to a job site with his tools and piece by piece he builds a house. He lays the foundation, frames the walls, puts on the roof. It's a beautiful, solid house, but it takes him 3 months. If you ask him to build an identical house next door, it will take him another 3 months. If a tornado levels the first house, he has to start from scratch, another 3 months of manual labor. Now meet the second builder, Alex. Alex doesn't show up with a hammer. He shows up with a blueprint and a button. He has spent those first 3 months designing a master blueprint and building a factory. When you ask him for a house, he pushes the button. A fleet of automated machines, following the blueprint, constructs the entire house in 3 days. If you ask for an identical house next door, he pushes the button again. 3 more days. If a tornado levels the first house, he just pushes the button one more time. The house is back exactly as it was in 3 days. In the world of cloud computing, for years we were all Chris. We would log into the AWS or Azure console, click through menus, configure virtual machines, set up networks, and manually build our infrastructure. It worked, but it was slow, prone to human error, and impossible to replicate perfectly. The person making $150,000 a year is Alex. They don't build things by hand. They write the blueprints. That is the essence of infrastructure as code, or IAC. You are no longer a digital construction worker. You are a digital architect. You don't configure servers, you write code that defines what those servers should look like, and an engine builds them for you perfectly every single time. This isn't just a neat trick. This is the fundamental pillar upon which modern technology companies are built. Think about Netflix. When you press play, you are one of millions of people doing it at the same time. Do you think there's a team of engineers frantically clicking to launch more servers every time a new season of a hit show drops? Absolutely not. Code does it. Code written months in advance anticipates the demand and automatically builds, scales, and even tears down the infrastructure needed. That is the power we are talking about. So why is this the highest paid skill? Comes down to 3 things: speed, safety, and scale. Speed is obvious. Deploying a complex, multi-tiered web application manually could take a team of engineers weeks. With a well-written IAC script, it can take minutes. For a business, that's the difference between launching a product this quarter or next year. Safety is about consistency. The single biggest source of outages and bugs used to be configuration drift. A tiny, undocumented change made by an engineer on one server that wasn't made on the others. IAC eliminates this. The code is the single source of truth. The infrastructure in the real world must match the blueprint. This de-risks everything. It means you can have a development environment, a testing environment, and a production environment that are 100% identical, killing the classic "but it works on my machine" problem forever. And scale is the holy grail. With IAC, the effort to build 10 servers is the same as the effort to build 10,000. You just change a number in a file from 10 to 10,000 and the automation handles the rest. This capability is what allows startups to become global giants overnight. So how do you, sitting here right now, acquire this superpower? You learn the tools of the trade. And in the world of IAC, while there are many tools, one stands above all others as the undisputed king of the job market: Terraform. Terraform, created by a company called HashiCorp, is the universal language for building infrastructure. Think of it like this: AWS has its own language for its APIs. Azure has its own different language. Google Cloud has a third. Learning to build on all 3 manually would be like learning to speak English, Mandarin, and Russian. Terraform is the universal translator. You write one set of blueprints in Terraform's simple language, and it can translate your request to AWS, Azure, Google Cloud, and hundreds of other services. This is why companies love it. They aren't locked into a single cloud provider. An engineer who knows Terraform can be productive on any cloud platform. For you, this means your skills are portable and in demand everywhere. Learning Terraform is the single best investment you can make in your cloud career after learning the fundamentals. Now, the cloud providers have their own native tools. AWS has CloudFormation, Azure has ARM templates, and Google has Cloud Deployment Manager. You should know that they exist. But they are like learning the specific dialect of a single village, while Terraform is the global language of business. These native tools lock you into one ecosystem. Terraform sets you free. When you look at job descriptions for cloud engineer, DevOps engineer, or site reliability engineer in the United States, you will see Terraform listed as a required skill over and over and over again. Master this and you become instantly valuable. So what's the plan? How do you go from zero to a Terraform hero? First, a mindset shift. From this day forward, you will fight the urge to build things by clicking in the AWS console. The console is for looking, for verifying. It is not for creating. Every time you want to create a server or a network, your first thought should be, how do I write the code to do this? Second, you're going to download Terraform. It's a single free file. That's it. You're going to install the AWS CLI, the command line tool we talked about, and configure it with your credentials. Third, you will do your Hello World project. Don't try to boil the ocean. Your first goal is simple. Write a Terraform file that defines and creates one single EC2 instance, that's one virtual server, in your AWS account. Add a security group that allows you to access it. Run the command Terraform apply, and watch as the magic happens. Watch as the code you wrote becomes a real running server in an Amazon data center. Then run Terraform destroy and watch it vanish. That feeling of control is addictive. Once you've done that, you need to learn the core concepts. Don't just copy and paste code. Understand the building blocks. You need to learn about providers, which are the plugins that let Terraform talk to AWS or Azure. You need to understand resources, which are the things you're building, the servers, the databases, the load balancers. Learn about variables so you can make your code reusable instead of hard coding everything. And learn about outputs so your code can report back information like the IP address of the server it just created. But the most critical concept in Terraform is the state file. This is Terraform's brain. It's a file that keeps a record of everything Terraform has built for you. It's the map that connects your code blueprint to the real infrastructure in the cloud. You must learn to respect the state file. It's what allows Terraform to know what needs to be changed, added, or deleted when you update your code. It's also why you never ever manually delete something that Terraform built. If you do, Terraform's map will be wrong, and chaos will follow. After you master the basics, you'll graduate to using modules. A module is a reusable package of Terraform code. Imagine you've perfected the code to create a secure, scalable web server. You can package that code into a module. Now, anytime you or your team needs a new web server, you don't rewrite the code. You just call the module. It's like creating your own custom Lego brick. This is how you go from building single servers to orchestrating entire systems. Now, it's important to understand a key distinction here. Terraform and infrastructure as code are primarily for provisioning the infrastructure. They build the house. They pour the concrete, put up the walls, and connect the plumbing. But they don't typically furnish the house. What does that mean? Terraform will create a brand new, empty virtual server for you. But it won't install your web server software. It won't configure your firewall rules inside the operating system. And it won't deploy your application code. That's a separate, but related, discipline called configuration management. Tools like Ansible, Chef, and Puppet handle that part. They are the automated interior decorators. For now, your focus should be 100% on mastering IAC with Terraform. That is the bigger hurdle and the more valuable initial skill. The person who can build the entire apartment complex is more valuable than the person who can only furnish one apartment. First, learn to build the city. This skill, this ability to define an entire data center in a handful of text files and deploy it in minutes, is what separates a junior admin from a six-figure cloud architect. It's a force multiplier for your career. The engineer who can codify their knowledge into a reusable, automated blueprint is 10, 50, even 100 times more effective than one who can only perform tasks manually. And in corporate America, value is what gets rewarded. The person who can save the company millions in engineering hours and prevent costly outages by automating infrastructure isn't just another employee. They are a strategic asset. They are the one who gets the $150,000 job. So get started. Download the tool. Write that first file. Create that first server from code. Because you're not just typing text into a file. You are writing the future. You are building the automated world. And in the next part, we're going to take these blueprints and put them on an assembly line. We're going to talk about building the automated factory itself. This factory isn't made of brick and mortar. It doesn't have smokestacks or a noisy assembly line with sparks flying. This factory exists entirely in code. It's the digital heart of every modern tech company, from the smallest startup in a garage in Austin to the sprawling campuses of Silicon Valley. We call this factory the CI/CD pipeline. Continuous integration and continuous deployment. And understanding how to build and run this factory is what separates the six-figure earners from everyone else. Think about how things used to be done. Let's call it the artisan era of software. A team of developers would spend months, maybe even a year, hammering away at code on their individual computers. It was like a bunch of master craftsmen in separate workshops, each building one part of a car. One guy builds the engine, another the transmission, another the chassis. They all promise their part works perfectly. Then, on integration day, they try to bolt it all together. And it's a disaster. The engine doesn't fit the chassis. The transmission grinds against the axle. Nothing works. What follows is a frantic, all-hands-on-deck, pizza-fueled nightmare of sleepless nights trying to fix it before the big launch. This was the reality. It was slow, it was risky, and it was incredibly expensive. Now imagine a modern Tesla Gigafactory. It's a symphony of automation. Every time a new component is designed, it's immediately tested to see if it fits with the rest of the car. Robots weld, test, and move parts with incredible precision. The line never stops. By the time a car rolls out the door, it's already been through thousands of automated quality checks. It's fast, it's reliable, and it can produce at a scale the old artisan model could never dream of. That, right there, is the difference between the old way and the CI/CD way. The CI/CD pipeline is your software gigafactory. It's the automated process that takes your code, your infrastructure blueprints from the last section, and automatically builds, tests, and deploys it. Let's break down the name. CI, continuous integration. This is the first half of our assembly line. It's the quality control station. In the old days, developers might go weeks without combining their code with the main project. With continuous integration, every time a developer makes a small change, even just one line of code, and adds it to the central code repository, a process kicks off automatically. The system takes that new piece, integrates it with the whole, and runs a battery of automated tests. Does the application still build? Do all the core features still work? Does this new change break something on the other side of the system? You get an answer in minutes, not months. It's a constant, relentless focus on quality, catching tiny problems before they become catastrophic failures. Then comes the CD. This can mean two things: continuous delivery or continuous deployment. They sound similar, but the distinction is important. Continuous delivery is like the car rolling off the assembly line, fully tested, polished, and ready to go, and parking itself in the showroom. The final step, handing the keys to the customer, still requires a human to press a button. The business decides when to release the new version. Maybe they want to time it with a marketing campaign. The key is, it's ready at a moment's notice. Continuous deployment is the final frontier of automation. The car not only rolls off the line, but a robot arm puts the keys in the ignition, and it drives itself right to the customer's driveway without any human intervention. Every single change that passes all the automated tests is deployed directly to production to real users immediately. This is how companies like Amazon, Netflix, and Google can update their massive applications hundreds or even thousands of times per day. This automated factory isn't built with just one tool. It's an ecosystem of tools working together. And the absolute, non-negotiable foundation of it all is something we've mentioned before: Git. Git is the master source of truth. It's the digital warehouse that stores every version of your blueprints. Platforms like GitHub, GitLab, and Bitbucket are the collaborative workspaces built around that warehouse. This is where the team works. It's the first thing you need to master. Now, for the factory machinery itself, the CI/CD platform. This is the software that actually runs the pipeline. The classic old-school powerhouse is Jenkins. Jenkins is like the reliable heavy-duty Ford F-150 of the CI/CD world. It's been around forever, it's endlessly customizable, and it can do absolutely anything. But it can also be a bit clunky and requires a lot of setup and maintenance. It's a powerful tool to know, and you'll see it in a lot of established companies. But the modern approach, and the one I strongly recommend you start with, is GitHub Actions. If GitHub is the workshop where you design your blueprints, GitHub Actions is like having the entire automated assembly line built right into the same building. It's seamless. You write your pipeline as a simple text file, another YAML file, just like your infrastructure code, and place it right alongside your application code. It's elegant, it's powerful, and it's incredibly easy to get started with. GitLab has its own fantastic, tightly integrated version called GitLab CI/CD, which works on the same principle. And of course, the big cloud providers have their own tools for this. AWS has its code pipeline suite, and Microsoft has Azure DevOps. They are all designed to work perfectly within their respective clouds. For a cloud professional, knowing the native CI/CD tools for your chosen platform is a massive advantage. But here's the most important secret. Learning these tools isn't just about learning tools. It's about learning a philosophy. The philosophy is called DevOps. This is a term you will see on every high-paying job description in this field. DevOps is about breaking down the wall between the people who write the code, developers, and the people who run the code in production operations. In the old world, these two teams were often at odds. The developers would throw the code over the wall to operations, and if it broke, it was their problem. DevOps says that's a stupid way to work. The team that builds the software should be responsible for running it. This culture of shared responsibility is enabled by the CI/CD pipeline. The pipeline is the common ground. It's the automated contract between dev and ops. By learning to build these pipelines, you are not just a systems administrator or a junior developer. You become a DevOps engineer. You are the person who builds and maintains the factory. You are the one who enables the entire company to move faster and more reliably than the competition. You are the productivity multiplier. And that is why DevOps engineers are paid so handsomely. They are the force multipliers for the entire technology organization. So what's your action plan? First, get comfortable with Git and GitHub. Create a repository. Learn how to commit, push, pull, and create branches. This is the language of modern software development. Second, pick a CI/CD tool. I recommend GitHub Actions and build a simple pipeline. Create a basic Hello World web page. Then, write a GitHub action that, every time you push a change to your code, automatically deploys that web page to a free service like GitHub Pages. When you do this, you will have completed a full end-to-end project that mimics exactly what happens in the real world. You can put that on your resume. You can talk about it in an interview. You have gone from someone who just writes code to someone who builds automated systems. You have built your first tiny automated factory. You've now learned how to write the blueprints for your infrastructure as code, and you've just built the automated factory to bring those blueprints to life. The assembly line is running. But what are we putting on that assembly line? What are the standardized, perfectly uniform building blocks that this factory will use to construct our applications? We need a way to package our code and all its dependencies into a single, predictable, lightweight unit that can run anywhere. We need the modern equivalent of the shipping container. And that is exactly what we're going to build in the next section. We're going to master the single most disruptive technology of the last decade, Docker. So let's talk about that modern shipping container. Imagine for a second you're a software developer in 2012. You spend weeks building a beautiful, complex application on your laptop. It runs perfectly. You use a specific version of Python, a specific database, and a dozen different libraries that all need to be just right. You hand it over to the operations team to deploy it on the company's servers. And then you hear the 5 words that have caused more arguments, more late nights, and more pure rage than any other phrase in tech history. It doesn't work on my machine. The operations team server has a slightly different version of Python. A library is missing. A configuration file is in the wrong place. And now everything is broken. This was the reality. We called it dependency hell. And it was a real multi-billion-dollar problem. Onboarding a new developer could take days of painstaking setup, trying to replicate an environment that might never be exactly the same. The first attempt at a solution was the virtual machine, or VM. A VM is basically an entire computer, including the operating system, emulated in software. So you'd package your app inside a whole copy of Linux. It worked, but it was a sledgehammer to crack a nut. These VMs were massive, we're talking gigabytes in size. They were slow to start up. And running a dozen of them on a single server would bring even the most powerful hardware to its knees. It was inefficient and expensive. We needed something better. We needed to package just the app and its direct dependencies, not the entire operating system. We needed a standard unit that didn't care what machine it was running on. We needed a shipping container for code. And in 2013, a small company called .cloud released an open-source project that would change everything. They called it Docker. Docker introduced the concept of the container. A container is a lightweight, standalone, executable package of software that includes everything needed to run it. The code, a runtime, system tools, system libraries, and settings. But here's the magic trick. Unlike a VM, a container doesn't bundle a full operating system. Instead, all containers on a machine share the host machine's operating system kernel. This makes them incredibly small, often just megabytes in size, and allows them to start in a fraction of a second. This is the build once, run anywhere dream made real. You build your application inside a Docker container on your MacBook. You can then hand that exact container to your colleague who uses Windows, or deploy it to a server in an Amazon data center running Linux, and you have a 100% guarantee that it will run exactly the same way. Every single time. That it works on my machine. Problem solved. Forever. So how do you, the aspiring cloud engineer, master this? It boils down to understanding 3 core concepts: the Docker file, the image, and the container. First, the Docker file. Think of this as the recipe or the blueprint. It's a simple text file, written with a series of commands. It says things like, start with a lightweight version of Ubuntu Linux. Then install Python version 3.9. Next, copy my application code from my computer into the container. And finally, when the container starts, run this specific Python script. It's a step-by-step instruction manual for building your environment from scratch. It's simple, it's readable, and it's the foundation of everything. Second, the image. When you run the Docker build command on your Docker file, Docker reads your recipe and creates what's called an image. An image is a read-only template. It's the final packaged-up version of your application and all its dependencies. It's the mold. It's the stack of Tupperware, all identical and ready to be filled. You can store this image on your machine, or better yet, push it to a registry like Docker Hub, which is essentially a GitHub for Docker images. Third, the container. This is the main event. A container is a running instance of an image. Using that single image you built, you can launch 1, 10, or 1,000 identical containers. Each one is a perfectly isolated, running copy of your application. If one crashes, the others are unaffected. Need more capacity for your website? Just launch more containers. It's that simple. This is not just theory. This is your next set of marching orders. Your path to that $150,000 salary continues right now. I want you to go to docker.com and install Docker Desktop. It's free for personal use on both Mac and Windows. Get it running. This is your new workshop. Your first assignment is the hello world of the container age. You're going to open your terminal and type one simple command to run a pre-built Nginx web server. You'll see Docker automatically download the Nginx image and start it as a container on your machine in seconds. You'll be able to go to your web browser and see the Nginx welcome page. That's your first win. You've just run a production-grade web server, the same kind that powers millions of websites with a single line of code. Feel that power. Next, you're going to take that simple Python web app or that Node.js script you wrote in the last section, and you're going to containerize it. You will create your very first Docker file. You'll learn the basic commands. From, copy, run, cmd. You'll build your own custom image that contains your code, and then you'll run it. You will see your own application that you wrote running inside a secure, isolated, portable container on your own machine. Then you're going to take it one step further. You're going to create a free account on Docker Hub, and you are going to push your first image to that public registry. This is a huge milestone. You've now created a portable software artifact that can be downloaded and run by anyone, anywhere in the world with a single command. You now have a skill that is listed as a requirement on tens of thousands of high-paying job descriptions. Why is this one skill so valuable? Because it's the bedrock of modern software development and operations, or DevOps. Companies that adopt Docker see a massive increase in productivity. Developers can build and test faster. The operations team can deploy with confidence, knowing there won't be any surprises. When a new engineer joins the team, they don't spend their first week installing software. They run one command, Docker Compose up, and the entire development environment for a massive, complex application spins up on their laptop in minutes. This speed is a competitive advantage, and companies will pay a premium for engineers who can create and manage this workflow. It also unlocks true scalability. Remember our e-commerce site on Black Friday? With containers, you don't need to manually set up new servers. You have a system that automatically detects high traffic and says, "We're getting swamped. Launch 200 more copies of the web server container now." And within seconds, those 200 containers are up and running, happily serving customers. When traffic dies down, the system automatically shuts them down, saving money. This elastic on-demand infrastructure is the holy grail of cloud computing, and it all starts with the humble Docker container. You've now mastered the fundamental building block. You can take any piece of software and package it into a standard, reliable unit. You've built the shipping container. But what happens when you have hundreds or even thousands of these containers? What happens when your application is made of 10 different microservices, all in their own containers, that need to discover and talk to each other? How do you manage updates? How do you handle it when a server goes down and you need to move all its containers to a healthy server automatically? Running one container is easy. Orchestrating a fleet of thousands across a global network of servers is one of the most complex challenges in modern computing. You've built the shipping container, but now you need the port, the cranes, the ships, and the global logistics network to manage it all. Solving this problem of container orchestration is the final technical pillar of your journey, and mastering it is what separates a good cloud engineer from a great one. It's the one skill that will truly unlock that $150,000 plus salary. It's time to build the skyscraper. It's time to learn the undisputed king of the cloud-native world, the system that runs behind the scenes at Google, at Netflix, at Spotify, and almost every major tech company on the planet. It's time to learn Kubernetes. But what even is Kubernetes? Let's cut through the noise. Imagine you're the logistics manager for the largest shipping company in America. In our last step, you learned about Docker containers, those standardized shipping crates that can hold any kind of cargo, or in our case, any application. This was a revolution. But now, you don't just have a few dozen crates. You have tens of thousands. They need to be shipped to cities, servers all across the country. What happens if one of your delivery trucks, a server, breaks down on the highway? How do you automatically reroute all its cargo to other trucks? What happens when it's Black Friday, and you suddenly need to scale from 10,000 trucks to 200,000 to handle the demand, and then scale back down on Tuesday to save money? How do you ensure that the crates carrying the website shopping cart can talk to the crates carrying the credit card processing system, securely and instantly, no matter which trucks they're on? Trying to manage this by hand with spreadsheets and a team of people frantically making phone calls would be pure chaos. It would be impossible. You would fail. This was the exact problem that the biggest tech companies in the world were facing. They had thousands of containers and managing them was a nightmare. That's where Kubernetes comes in. Kubernetes is not the truck. It's not the cargo. Kubernetes is the master logistics and dispatch system. It's the central command center with a god's eye view of the entire country. Every truck, every crate, every route. It automates everything. You don't tell it, hey, put this container on that specific server in Ohio. That's the old way. Instead, you just declare your intent. You say, hey Kubernetes, I need to be running 50 copies of my web server at all times. I don't care where you run them, just make it happen. Oh, and make sure they can talk to my database. And if any of them crash, I want you to instantly spin up a new one to replace it without waking me up at 3 a.m. And Kubernetes just says, got it. It finds the healthiest servers with the most capacity, places your containers, connects them, and constantly monitors them. A server in Virginia goes offline? Kubernetes already detected it, moved the containers to a server in Oregon, and rerouted all the traffic before your first customer even noticed. A sudden surge of traffic from a Super Bowl commercial? Kubernetes sees the spike and automatically scales your application from 50 copies to 500 in seconds, then scales it back down when the game is over, saving you a fortune on your cloud bill. This is the power of Kubernetes. It's a system for orchestrating containers at massive scale, built with the same principles Google uses to run services like Gmail and YouTube. It provides self-healing, auto-scaling, and service discovery. In short, it allows companies to run their applications with the same resilience and efficiency as the biggest tech giants on the planet. And that is why companies are willing to pay a fortune, easily pushing you into that $150,000 bracket, for people who understand how to wield this power. A skilled Kubernetes engineer isn't just managing servers. They are the architect of a resilient, automated, money-making machine for their company. So how do you learn it? How do you become this high-demand architect? This is where many people get intimidated, but we're going to break it down into a clear, manageable path. First, you're not going to start by spending hundreds of dollars in the cloud. You're going to learn it right on your own laptop. You'll install a tool like Minikube or enable the Kubernetes engine that's built right into Docker Desktop. This gives you a complete single-node Kubernetes cluster on your own machine for free. This is your personal sandbox. This is where you'll learn the fundamentals without fear of breaking anything or running up a bill. Your first mission is to understand the core building blocks. You'll start with pods. A pod is the smallest unit in Kubernetes. Think of it as a little wrapper around one or more of your Docker containers. Then you'll learn deployments. A deployment is where you declare your desired state, like telling Kubernetes, I always want 3 identical pods of my web application running. And then you'll learn services, which is the crucial piece that gives your pods a stable network address so other parts of your application and the outside world can actually find them. Pods, deployments, and services. That's it. Focus on mastering just those 3 concepts first. Get hands-on. Write the simple configuration files called YAML files to deploy a basic application, scale it up, scale it down, and expose it so you can access it in your web browser. Once you're comfortable deploying applications in your local sandbox, it's time to graduate to the real world. Managed Kubernetes in the cloud. Every major cloud provider, AWS, Google Cloud, and Azure, has their own managed Kubernetes offering. On AWS, it's called the Elastic Kubernetes Service, or EKS. On Google Cloud, it's the Google Kubernetes Engine, GKE, and on Azure, it's the Azure Kubernetes Service, AKS. The beauty of these managed services is that the cloud provider handles the incredibly complex task of running the Kubernetes brain. the control plane. This frees you up to focus on what really matters: deploying and managing your applications. Your skills from your local setup will transfer directly. You'll just be pointing your commands at a real powerful cluster in the cloud instead of your laptop. Pick one provider, whichever one you chose back in step 3, and learn their managed service inside and out. Now you're getting dangerous. You can deploy, scale, and manage applications on a real-world, production-grade system. But to truly become elite, you need to understand the ecosystem that surrounds Kubernetes. This is the Cloud Native Computing Foundation, or CNCF, landscape. And I'll warn you, the first time you see the chart of all the tools, it looks terrifyingly complex. But you don't need to learn them all. You just need to learn about the key categories and the leaders in each. First is observability. How do you know what's happening inside your cluster? The answer is a tool called Prometheus for gathering metrics, and Grafana for creating beautiful dashboards to visualize those metrics. You'll learn how to see your application's health, CPU usage, and traffic in real time. Next is GitOps. This is a revolutionary idea for deploying applications. Instead of manually running commands to update your app, you use a tool like Argo CD. You simply push your new code and configuration to a Git repository, and Argo CD automatically detects the change and updates the cluster to match. It's a completely automated, auditable, and reliable way to manage your applications. Finally, while you're learning, you should be aiming for a certification that proves you have what it takes. The gold standard in the industry is the Certified Kubernetes Administrator, or CKA exam. This isn't a multiple-choice test. It is a grueling, hands-on, command-line-only exam where you are put into a live Kubernetes environment and tasked with fixing broken clusters and deploying applications under a tight time limit. It is tough, but passing it is a signal to every recruiter and hiring manager in America that you are not a pretender. You have proven, practical, real-world Kubernetes skills. It is one of the single most valuable certifications you can earn in your tech career. Learning Kubernetes is your entry into the world of cloud-native engineering. It's the skill that separates the cloud administrators of yesterday from the six-figure DevOps and site reliability engineers of today. You've learned how to build the containers. You've now learned how to orchestrate them like a master conductor leading a symphony. You have the blueprint for the modern, resilient, scalable application. But there's a final crucial piece of the puzzle. You've designed this incredible, complex Kubernetes city. But how do you build that city, the networks, the servers, the databases, the entire foundation from scratch in minutes? And how do you do it perfectly, identically, every single time with just the push of a button? The answer is a philosophy, a paradigm shift that has completely revolutionized how we think about technology infrastructure. It's called Infrastructure as Code, or IAC. And the undisputed king of this world, the tool that companies from Netflix to Starbucks are betting their futures on, is Terraform. Think of it like this. Before Infrastructure as Code, setting up a new server environment was a manual, artisanal craft. A system administrator would log into the AWS or Azure console and start clicking. Create a network here. Launch a server there. Configure a firewall rule over here. We call this ClickOps. And it's a recipe for disaster. Why? Because humans make mistakes. Maybe on a Tuesday you forget a tiny security setting. Maybe you configure the server in Virginia slightly differently than the one in Ohio. This inconsistency, this configuration drift, is the silent killer of reliability. One small, undocumented change made by hand at 2 a.m. can bring a billion-dollar company to its knees. And worse, how do you rebuild it if it all goes down? You can't. Not exactly. It's like trying to rebuild a house from memory. You'll get it mostly right, but you'll forget where a few key support beams go. Infrastructure as Code throws that entire manual process in the trash. Instead of clicking buttons, you write a file. A simple, human-readable text file. In this file, you declare the state of the world you want to create. You don't tell it how to do it, you just describe the what. You write, I want 3 web servers of this specific size, 1 database with this much storage, and a network that connects them, allowing traffic only on these specific ports. You write it down like a blueprint for a skyscraper. Then you hand that blueprint to Terraform. Terraform reads your file, looks at your cloud account, your empty plot of land, and it calculates the most efficient way to build your skyscraper. It says, okay, to get to your desired state, I need to perform these 27 steps in this exact order. You type one command, Terraform apply, and you hit enter. And then you lean back and watch the magic happen. Terraform goes to work, an army of perfectly precise digital construction workers, building your entire infrastructure from the ground up. exactly as you specified in your blueprint. In minutes, what used to take days of error-prone clicking is standing before you, perfect and ready to go. And here's the most powerful part. That blueprint is just a text file, which means you can save it, you can share it, you can put it in Git, the same version control system that software developers use. Now, your entire infrastructure has a history. You can see who changed what, when they changed it, and why. If a change causes a problem, you can roll it back instantly, just like rolling back a software bug. If you need to create an identical copy of your entire production environment for testing, you don't spend a week clicking. You just run the same script. Push-button replication of unimaginably complex systems. This isn't just a convenience. It is a superpower. Let's make this real. Imagine a rapidly growing online retailer based out of Nashville, preparing for the Black Friday rush. In the old world, they'd spend weeks manually provisioning and configuring hundreds of extra servers, hoping they got it right. It's a stressful all-hands-on-deck nightmare. With Terraform, it's a non-event. They have a script, a blueprint for their peak traffic configuration. A week before the sale, a single engineer runs Terraform apply. The extra capacity spins up, perfectly configured. The sale happens, they make millions. The Monday after, they change one line in their script, from server_count equals 200 to server_count equals 20, and run Terraform apply again. Terraform gracefully tears down the extra 180 servers, and their cloud bill plummets. This is the agility that modern American businesses are paying a fortune for. They need people who can wield this power. So, how do you become one of those people? Your journey into infrastructure as code starts with the Terraform fundamentals. First, you need to understand the basic building blocks. You'll learn about providers, which are the plugins that let Terraform talk to AWS, Google Cloud, Azure, and hundreds of other services. You'll learn about resources, which are the things you're actually building: a virtual server, a database, a network. Then you'll master variables to make your blueprints reusable, and outputs to extract important information, like the IP address of a server you just created. Your first project should be simple but empowering. Your mission is to write a Terraform file, maybe 15 lines long, that creates a single EC2 instance of virtual server in AWS. You'll run Terraform apply and watch it appear in your AWS account. Then, 5 minutes later, you'll run Terraform destroy and watch it vanish. That moment when you create and destroy real infrastructure with nothing but a text file and a command is when it all clicks. You'll feel the immense power at your fingertips. From there, you scale up. You'll learn about modules. Modules are the secret to managing complexity. They are like custom Lego bricks. You build a perfect, secure, and well-configured web server module once. Then anytime you need a new web server, you just use your custom brick. Need 10 of them? You just stamp it out 10 times. This enforces consistency and best practices across an entire organization. Finally, you'll touch on the concepts that separate the pros from the amateurs: state management and remote backends. Terraform keeps a state file to remember what it has built. When you work on a team, you can't have that file living on your laptop. You learn to store it centrally, in a place like an AWS S3 bucket, using a remote backend. You'll also learn about state locking, which prevents two engineers from accidentally trying to modify the same infrastructure at the same time and causing catastrophic conflicts. These aren't just features. They are the bedrock of professional, collaborative infrastructure management. Mastering a tool like Terraform is what elevates you from someone who uses the cloud to someone who builds and commands the cloud. When you can combine the container orchestration skills of Kubernetes with the infrastructure automation power of Terraform, you become one of the most valuable assets in the entire tech industry. You're no longer just managing servers. You are an architect of scalable, resilient, and automated systems. You are the person who can save a company millions in wasted cloud spend and prevent the outages that lose them millions more. This is why a cloud engineer or a DevOps engineer who has deep expertise in both Kubernetes and Terraform is easily commanding salaries north of $150,000. It's not an inflated number. It's a direct reflection of the immense business value you can provide. You've now learned how to define the infrastructure with code and build the city with Terraform. You know how to run your applications inside that city using Kubernetes. But there's one final, critical piece of the puzzle. How do you get new code, a new feature, from a developer's laptop through testing and deployed into your Kubernetes city safely, automatically, and potentially hundreds of times a day? How do you build the automated superhighway that connects the world of software development to the world of production operations? The answer is DevOps. And the engine that powers it is called CI/CD, which stands for Continuous Integration and Continuous Deployment. This is the final crucial piece of the puzzle. This is the capstone on your pyramid of skills. Think of it like this. A team of brilliant chefs can cook amazing individual dishes. But to run a Michelin star restaurant that serves hundreds of people a night, you need more than just great chefs. You need a system, an assembly line, a process where ingredients are prepped, cooked, plated, and sent out flawlessly, consistently, and at high speed. That's what CI/CD is for software. It's the automated factory assembly line for your code. It's the digital superhighway you were asked to build. Continuous integration is the first part. Every time a developer writes a new piece of code, a new feature, a bug fix, they don't just save it to their own computer. They merge it into a central shared codebase, usually managed by a system called Git. The moment they do that, an automated process kicks in. This process, run by tools like Jenkins, GitLab, or GitHub Actions, immediately grabs that new code, builds the entire application, and runs a whole suite of automated tests. Is the new code compatible with the old code? Did it break anything? Does it pass all the quality checks? This happens automatically, continuously, for every single change. It catches errors early, when they're small and cheap to fix, instead of late, when they're buried deep in the system and have become a catastrophic failure. If all those tests pass, we move to the next stage. Continuous deployment. This is where the magic really happens. The same automated system takes that newly built, freshly tested, and fully approved version of the software and deploys it. Pushes it out into the world. It updates the application running in your Kubernetes cluster, on your AWS servers, for your end users to see. All without a human manually clicking a deploy button. This is how companies like Netflix, Amazon, and Google can update their massive, complex applications hundreds, even thousands of times a day. They have built an incredibly sophisticated, automated, and reliable factory for their code. And you, with this final skill, become the architect of that factory. You are the one who designs the assembly line. You understand the source, the developer's code in Git. You understand the machinery, the build servers and testing frameworks. And you understand the destination, the Docker containers running in a Kubernetes cluster on a major cloud platform. You are the one who connects it all together, making it seamless, fast, and safe. This is the essence of the DevOps philosophy. It's about breaking down the old walls between the people who write the code, the developers, and the people who run the code in production, the operations team. By automating the entire process, you create a culture of collaboration, speed, and reliability. This is one of the most sought-after skill sets in the entire tech industry right now, because it is the ultimate business multiplier. It allows companies to innovate faster, respond to market changes quicker, and deliver more value to their customers with less risk. So let's take a step back. Let's look at the entire skyscraper you've just mapped out. You started at the foundation with the absolute fundamentals of IT, networking, and operating systems like Linux. You built the first floor with a programming language, Python, giving you the power to automate and script. Then you chose your skyscraper's location, AWS, Azure, or Google Cloud, and became an expert in its core services. You learned how to build the rooms and offices inside, using infrastructure as code with Terraform. You learned how to furnish those rooms efficiently and consistently, using containers with Docker. You then became the city planner, learning how to manage thousands of those rooms at scale using Kubernetes. And finally, you built the automated transit system, the superhighways of CI/CD, connecting everything and allowing value to flow from idea to customer in minutes instead of months. Look at what you've become. You're not just a cloud guy. You're not just a Linux admin or a Python coder. You are a full-stack infrastructure engineer. You are a cloud architect. You are a DevOps professional. You are the person who can see the entire chessboard. When a company wants to build a new application, you don't just see one piece of the puzzle. You see the whole system, from the first line of code written by a developer, to the global infrastructure it runs on, to the automated pipelines that deliver it. You are the one they will pay $150,000 or more to, because you don't just solve one problem. You build the engine of modern technology. But building this engine requires more than just technical skills. There's a layer of glue that holds all of this together. It's the professional skills, the so-called soft skills, that are actually the hardest and most valuable of all. It's your ability to communicate complex ideas simply. It's your ability to collaborate with a team, to listen, to explain the why behind your technical decisions. It's your relentless curiosity and your commitment to being a lifelong learner. Because this field changes not year by year, but month by month. And it's about building your personal brand. Your resume is no longer a Word document. Your resume is your GitHub profile, filled with projects you've built. It's a Terraform script that spins up a 3-tier web application. It's a Python script that automates a daily task. It's a simple CI/CD pipeline you configured with GitHub Actions. It's proof that you can do the work. Your professional network is no longer just the people you know. It's a curated LinkedIn profile where you don't just list your skills. You share what you're learning. You write about a problem you solved. You engage with other professionals in the field. You become a participant in the community, not just a spectator. So where do you go from here? The map is laid out before you. The path is clear. But a map is useless if you don't take the first step. The sheer amount of information can feel paralyzing. So I'm going to give you your first 3 steps. Your homework starting today. First, pick one thing and start. Just one. Don't try to learn Linux, Python, and AWS all at once. That's a recipe for burnout. Look at the roadmap and pick your starting point. If you're a complete beginner, start with the CompTIA A+ or Network Plus. If you have some IT background, start with the AWS Certified Cloud Practitioner. Just pick one, buy the course, read the book, watch the videos, and schedule the exam. Put your money and time on the line. Create accountability. Second, build something. Immediately. Don't fall into the trap of tutorial hell, where you just watch videos forever. Knowledge is useless without application. Your first project can be simple, incredibly simple. Your mission: launch a basic web server on a free tier AWS EC2 instance. That's it. This one small project will force you to learn about networking, security groups, Linux commands, and the AWS console. Once you do that, your next project is to deploy a simple Python Hello World application inside a Docker container on that same server. Then your next project is to automate the entire process with a simple Terraform script. You see the pattern? You learn, you build. You learn more, you build something better. Each project is a stepping stone, a tangible accomplishment that you can put on your GitHub. Third, document your journey in public. Create a LinkedIn profile and a GitHub account today. Every time you finish a tutorial, pass a certification, or complete a mini project, post about it. Not to brag, but to teach and to share. Write a short post. Today I learned how to configure an AWS security group. It was tricky, but here's what I figured out. You will be shocked at how quickly you connect with recruiters, hiring managers, and mentors. You're showing initiative, passion, and communication skills before you even step into an interview. This journey will not be easy. There will be nights you are staring at an error message, feeling completely stupid, wanting to quit. There will be moments of self-doubt. You will see the mountaintop and feel like you're still at the bottom. Every single person who has this job has felt that way. The difference is they didn't stop. They treated every error as a learning opportunity. They saw every failure not as a reflection of their worth, but as a tuition payment for their education. This roadmap is your guide. It is the collective wisdom of thousands who have walked this path before you. It is your key to a career that offers not just an incredible salary, but the security and freedom that comes with it. The freedom to provide for your family, to live where you want, to work on challenging problems that matter. This isn't just a path to a better job. For many Americans, this is a path to a different life. A life built not by chance but by choice. By the decision to learn, to build, and to persevere. The only thing standing between you and that $150,000 job is not a lack of talent or a lack of opportunity. It was a lack of a plan. And now, you have the plan. The map is in your hands. The work starts now. Go build your future.